Hello students, in the last video we have discussed the Newton's second law of motion and the relation between force, mass and acceleration, and what are the other impact of force and when the force is required. These things we will discuss in this video. In the second law of motion, we know the relation F equal to ma. Force equal to mass into acceleration. In the second law, we get force equal to mass into acceleration. If acceleration is zero, then F equal to m into 0 equal to 0. The force is equal to 0. To move a body with zero acceleration, that is constant velocity. To move a body with zero acceleration or constant velocity, no external force is required. Force is zero. No external force required. That means when a body travels with constant velocity, we don't require any external force to move the body with constant velocity. If the velocity changes and the body is accelerated, then external unbalanced force is required. That means for accelerated motion, for accelerated motion, an external unbalanced force is required. An external unbalanced force is required. Balanced force do not cause the change in state of rest or change in state of motion. Only unbalanced force causes the state of change in rest or state of change in motion or state of change in speed. So, external force, external unbalanced force is required. This is the first thing we know from second law, that to move the body with zero acceleration or constant velocity, no force is required. But for accelerated motion, an external unbalanced force is required. Another thing we will see from second law, I will erase it. What we see, we will prove now the second law is the real law and first law is contained in the second law. F equal to ma, but we know a equal to v minus u by t. Put v minus u by t. If that means f into t equal to m into v minus u. F into t equal to m into v minus u. If f equal to 0, then mv minus mu is equal to 0. Force in time equal to 0. That implies mv equal to mu. Mm cancel. That implies v equal to u. From this derivation, what we know, if force is 0, that means if no force is applied on the body, then the body travels with same initial velocity. The body travels with the same initial velocity u. That means final velocity v is equal to u. There is no change in velocity. Our first law states that a body is in the state of motion, it will continue to remain in its state of uniform motion. Same thing we know from this relation. If force equal to 0, then initial velocity u equal to final velocity v. That means the body travels with the same initial velocity if the force is not applied on it. On the other hand, if initial velocity, if the body is initially at rest, that is initial velocity u equal to 0, then also v equal to 0, u equal to v equal to 0. That means if the body is at rest and force is not applied on it, then the body will continue to remain in its rest, which is the first law. So, first law can be derived from the second law, or second law is the real law. From first law, what we get? We get the idea about the force. We get the idea about the force. What is force? What is force? That tells the first law. Second law gives the measure of force. Gives the measure of force. First law gives the qualitative idea about the force, and second law gives the quantitative definition of the force. Also, from the first law, we know the definition of inertia. So, first law also called the law of inertia. Now, second law of motion. Here, another thing we will discuss. When a batsman strike a ball with his bat, a huge force applied on the body for a very short interval of time. A huge force applied on that ball for a very short interval of time. This force is not constant, it's variable. If we draw a graph for this variable force, and we will take time in the x-axis and force in the y-axis, this will be the graph. It is very difficult to calculate the amount of force because it is variable. But we can calculate the impact of variable force by calculating the change in momentum. The change in momentum. Here we think From this relation, F into T equal to mv minus mu. mv means final momentum, mu means initial momentum. This F into T is equal to impulse. This is called impulse, Ri. Understand? When we catch a ball or a batsman hit a ball with his bats, a large force acting on the ball, which is variable. This variable force act on the body for a short interval of time is called impulsive force. This impulsive force, to measure this impulsive force is difficult, but we can measure the impact of this impulsive force by calculating the change in momentum. This is called impulse. That means impact produced by impulsive force is called impulse. How can we calculate it? By calculating the change in momentum. Or I equal to force into time, that is equal to mv minus mu. Its SI unit Newton meter per second, kg meter per second, or Newton second. CGS unit gram cm per second or dyne second. SI unit kg meter per second or Newton second. CGS unit gram cm per second or dyne second. To reduce the impact, what we have to do? We have to increase the time. To reduce the impact, we have to increase the time. And if time interval is less, then impact will be more. Lesser the time, impact will be more. More the time, impact will be less. That means if in less time, if momentum changes, then force exerted is more. If time elapsed to change the momentum is more, then force exerted is if time is less, then force will be more. If time more, then force will be less. We will discuss some examples. A person falling on a cemented road, he gets more hurt, but when he fall on a sandbag, he got less hurt. Why? In the first case, when he fall on the cemented floor, the time of change in momentum becomes very less. In very short time, its momentum changes. So the person gets more hurt. But when he fall on sandbed, the time of change in momentum is more, so that the person get less hurt. You will observe during the high jump, there provides a sandbed. Why? When the athlete jumps over and fall onto the ground and falling to the sandbed, the to change the momentum, more time is required, so that the athlete get less hurt. Similarly, you think other examples. There are so many examples. When a cricketer catches a ball, he pulls his hand backward. Why he do so? Because by pulling his hand backward, he take more time to change the momentum, so that he get less hurt to his hand. He get less hurt to his hand. There are other examples we will think. In cars, there provide seat belt. Why seat belt is there? If there is any accident, the passenger will go forward. To reduce this motion, there is a seat belt provided, by which there is change in momentum become less. There is change in momentum require more time, so that the less hurt will be there to the passenger. A carrot player blows his hands with very fast, so that a pile of tiles can be broken. In this case, what happens? In a very short interval of time, very short interval of time, momentum changes, so that a huge force applied on the pile of tiles, and tiles break down. Tiles break down. These are all about the impact of change in momentum or impulsive forces. When another example we will discuss, glasswares. When packed, they are packed with soft materials. While transporting, if there is jerk, then change in momentum becomes very less time, so glasswares may break. But when we pack the glasswares with soft materials, the change in momentum takes more time, so force impacted on the glasswares is less, and there is no breaking up of glass. These are all about the impact of impulsive force. In the next video, we will discuss third law of motion, law of conservation of momentum, and in the next videos, we will upload some numericals, important numericals. Thank you today. And if you like my video, use like, share, and subscribe it. Thank you, everybody.